We're right in the middle of number 2 on page 8 of your 3.2 notes. We had first to get x alone. So we picked x because it's the only variable that has a 1 in front, and we made a note up here, pick the variable with a 1 in front. So that's why we picked x. It wasn't random. It's the only one that had a 1 in front. That one has a 5, that has a 2, that has a 6. Why do we pick the one with 1 in front? Because if you pick 5, for instance, you're going to get fractions. Y equals 8 minus, or 8/5 minus 1/5 x. So you don't want ugly stuff like that. So if you pick the variable with a 1 in front, then you'll get nice whole numbers. So we had to do the opposite to move everything by itself because we're supposed to get that variable alone. So I subtracted 5y, made sure and didn't put it underneath the x. They're not like terms. Then I boxed it because we're going to come back to that. Then you go into the other equation and replace the x with 8 minus 5y because they are equivalent, which means they're the same thing. And keep that in parentheses. We distributed 16 minus 10y plus 6y. We had like terms, negative 10y plus 6y is negative 4y. So this is our new equation. 16 minus 4y equals 16. Now we're solving for y because we know how to solve when it's just one variable. So anything without a y needs to go to the other side by doing the opposite. And this is plus 16. So subtract 16. So we get negative 4y equals, this cancels, 16 minus 16 is 0. And remember, that does not mean no solution. You still solve it just like always. So the opposite of times negative 4 is divide by negative 4. So we get y equals 0. Nice. So I know this much. So I'm looking for the point of intersection, and I know y is 0. Now I need to find my x. And this is where your box comes into place. That's why I love substitution, because you just go right back to the box. So in place of y, you're going to put 0. So we'll get x equals 8 minus 5 times 0. X equals 8 minus 0, so x equals 8. And then you go up here and fill in your 8. So this is how you write your answer as an ordered pair, because remember, solving a system means you're finding the point where the two lines cross for us. Sometimes it's not going to be lines, but for us it will just be lines. Okay. Okay, so let's see how to check that. So we'll check this second one since it has a pretty nice solution. So I'm going to use a separate sheet of paper for that since we're kind of out of room. So you might want to get out a piece of notebook paper. So to check it, we have our solution 8, 0. We're going to write our two original equations. And this is what you would do if you have some extra time on the test at the end, which a lot of students tell me they usually do. So if you have extra time, go back, and any problem that says solve can always be checked, just like our equations. So, and you do have to check it into both, because checking it into one does no good. So we're going to put 8 in for x, 0 in for y, and see if we get a true statement. That's a definition of a solution, that when you plug it into the equation, it makes a true statement. And then we have to do the same thing here. 8 for x, 0 for y. So then we get 8 plus 5 times 0. And I want to know, is that going to give me this 8? I want to see if it makes a true statement. And sure enough, 8 plus 0, ding, ding, ding. So it checks the first equation. And the second equation, 2 times 8 plus 6 times 0. Does that give me, I forgot to put I said it but didn't write it, 16. So again, we have 0, so 16 equals 16. Boom. So I can walk away and go, yes, I know I got that one right because I just checked it and I got a true statement for both. True meaning the same number on both sides. It has nothing to do with your solution. It just has to be the same number on both sides. And if you have that, same number on both sides of the equal, that means it is a solution for both of those lines, or it is a point on both of those lines. So that's how you do the check. So you take your point, plug the first coordinate in for x, the second coordinate in for y, and make sure you get two true statements. Okay, let's go ahead and look at our next page. So take a look at the equations and see if you can pick which one we're going to solve for. And this might even be a good one for you to shut off the video and try on your own, because we just did 2. You have 2 as guides, so now you have one, because this one has fractions in it, number 4, so that might not be a good first one. So why don't you shut off the video and work on 3. Let's first pick which letter you're going to solve for. Not a 1, not a 1, not a 1, boom. This is -1, next best thing. So that's the letter you're going to get alone. So bring this down and shut off the video now, get y alone, and then plug it into the other equation. Turn the video back on, and then you can check with mine. Okay, so to get y alone, I have to do the opposite. Subtract 4x, because this is positive, and go over here and write subtract 4x. Remember, we don't want to put it under the 5 because they're not like terms. So the x's are gone on the left, which is our goal. And I want to remind you that -y means -1 times y. Sometimes students forget that, so it might be a good idea to write it like that. -y means -1 times y. On this side, I have 5 minus 4x. So a lot of students stop and box this, but y is not alone. I have a -1 in front of it, so I have to do the opposite to get it alone. So the opposite of times -1 is divide by -1. And remember, we learned in one of our first sections that whatever you do to one term, you have to do it to all the terms all the way across. You can't pick and choose. So every single term needs to be divided by -1. So this turns into positive 1y, or just y. I'm going to do this one first. So this turns into positive 4x, and a positive divided by a negative, that turns into -5. So 2 negatives in division's positive, so I just moved it up front. 1 negative in division's negative, and 5 divided by 1's 5. So now we have our boxed equation. So sometimes they make you work a little bit for that boxed equation. You need to work a little bit for that one. Okay, so here's the key point. Now you have to go into the other equation, take out y, and replace it with what it's equal to. So don't go back into itself. Go into the other equation, and that's why this is called the substitution method. In place of y, put 4x minus 5 in parentheses because it is a quantity. Write your new equation out and solve. So we have 4x plus 3 parentheses 4x minus 5, because that's what y is equal to, equals 3. And now I have an equation with all x's, so no problem. I can check that. When it's all x's, it's easy to check. So 4x plus 3 stayed the same. Take y out, put 4x minus 5 in, set it equal to 3. So then distributing and solving our equations like we learned in our first section of the semester, we have plus 12x minus 15 equals 3. So we learned the first thing you do is distribute parentheses. The second thing you do is combine like terms. So I can see we have 16x minus 15 equals 3. So 4x plus 12x, 16x minus 15 equals 3. So then we have to add 15 add 15, and we get 16x equals 18. So you can see this isn't going to be a nice pretty one like some of the others. So the opposite of times 16, divide by 16. So x equals, and usually we don't want a decimal, so it's better just to simplify the fraction. So they're both divisible by 2. So we get 9/8 as our x. So we know our order pair is going to be 9/8, comma, something. Okay, so everybody remember the next step? We know what x is, and that's why the box is there, begging you, come back to me. So in place of that x, you're going to put 9/8. And then we'll use the calculator to help us, not a problem. So y equals 4 times 9/8 minus 5. So we don't care how ugly the answer is because the calculator makes it so easy for us. So 4 times, and then 9 fraction bar 8, subtract 5. And it tells us it's -1/2. So y equals -1/2. So I know you're thinking, ooh, I don't want to check that one. But I think it would be a really good idea to check that one. So let's go back to our separate sheet of paper. Turn it around. So we have the order pair 9/8 and -1/2. So I'm going to put that at the top. And then I'm going to write my two equations. So 4x plus 3y equals 3. And you're probably thinking, oh, this is going to be an ugly check. Not at all. You're going to do it all on the calculator. So 9/8 goes in place of x and -1/2 goes in place of y. So 9/8, -1/2. 9/8, -1/2. So we want to know, does 4 times 9/8 plus 3, and remember the rule, when you're inputting a negative, it must be in parentheses. Parentheses -1/2. We want to know, does that give us 3 when we type it in the calculator? So let's see. I'm going to move this up so we can see the calculator. So just type it in just like you see it. So 4, let me get out of the glare so you can see. So 4 times 9 fraction bar 8 plus 3 parentheses negative at the bottom 1 fraction bar 2, close your parentheses, hit enter, ding ding ding, yes, that's when we do our happy dance, when the two sides match. So we got 3 from that side, we got 3 from this side, so that works. Now let's check the other one. So we want to know, does 4 times 9/8 minus -1/2. Remember, anytime you put a negative in, you have to close it in parentheses. And we want to know, when we type that in the calculator, will it give us 5? If it does, we can walk away and be happy. So this double negative is going to turn into a positive. Or you could have typed the double negative in the calculator. That just makes it easier. So we do 4 times 9 fraction bar 8 plus 1 fraction bar 2, hit enter, woohoo, 5 equals 5. So even though that was an ugly answer, we know we did it correct because we got 2 true statements when we plugged it into the original problem. So we'll start on the next problem in the next video.